Hello everyone, this is the continuation of the lesson Newton's Law of Motion, and in this topic we're going to discuss about the applications of second law of motion. Now let us try to examine the vector nature of Newton's Law of Motion by applying this principle directly into the sample problem. So let's go. Example: a man is stranded on a raft with a combined mass of man and raft that is equivalent to 1,300 kilograms, and by paddling he causes an average force of P, which is 17 newtons, to be applied to the raft in a direction due east. So this is towards positive x direction. The wind also exerts a force on a raft, and this force has a magnitude of 15 newtons and points 67 degrees north of east. And ignoring any air resistance from the water, find the x and y components of the raft's acceleration. And this is basically the applications of vector components in our previous lesson, and we're going to apply that here because force, as you know, is the example of vector quantity, and when we say vector quantity, it has both magnitude and direction. Okay, now first thing to do is to identify all the available given that we have in this sample problem. So the given here is also, we have the force of paddling, which is 17 newtons here, and we can also write this one as symbol, or we can denote this one as F sub P for us to write this one easily in the equation. And for the force of the wind, we have here available given, which is 15 newtons, and this is we can be denoted this one as F sub A. So this is F sub A, and also mass is 1,300 kilograms, and we have also angle here, which is 67 degrees directed towards north of east. So this is north of east, and we are required to find the x and y components of the acceleration. We're going to make a free body diagram applying or plotting this one in this value here, these forces that we have here, so that we can easily visualize what is the best method. Because we don't have a fixed formula here, I cannot give you a fixed equation here, because the very best approach that I can give you for us to solve for the vector nature of Newton's law of motion, particularly second law, is only the trial and error method. So we are going to analyze problem by trial and error. That is why I cannot give you fixed formula or fixed equation, because it depends on the problem. Okay, so let's use the trial and error method. But to do that, let's have a free body diagram first. Free body diagram. So let's try to analyze this statement here. By paddling, the average force of 17 newtons is directed due east. So we can partially draw here a coordinate system. This is positive x, or we can also call this one as east, and this is our positive y, or north. So the force of paddling is directed towards positive x direction. So we can label this one, change color. We can put here, this is our F sub P, and for the force of the wind, which is directed towards north of east with an angle 67 degrees, this one. So we will assume that this is 67 degrees. I'm just assuming that this is 67 degrees pointing north of east. So this is our F sub A with an angle of 67 degrees. So if you want to be more accurate, you can use your protractor by plotting this one, but in this case I'm just assuming that this is 67 degrees. Okay, so this is the free body diagram of our forces, and this will serve as the basis for us to analyze and interpret what is appropriate equations that we can derive from this body diagram here by using trial and error method. Now next to that is we're going to resolve the force isolate each force that we have here, the force of the paddling and the force of the wind. So resolve the x and y component by isolating this force here. So let's first isolate this the force of paddling here. So by copying this diagram here, or free body diagram here, let's assume that this is our force of paddling here, and this is F sub P, and this is also the F sub Px, and this is our F sub Py. So in terms of, this is very important concept here, for x component of F sub Px, the F sub Px here is equivalent to this one, this 17 newtons here, because according to the statement that we have here, it was stated here that the 17 newtons is directed towards positive x direction. So automatically we will now assume that 17 newtons is in the x component. So that should be our x or the F sub Px of our force of paddling. Now in terms of y component of F sub Py, the F sub Py here is equals to, since we don't have a force of relative to the force of paddling towards y component, so we will assume that F sub Py here is 0, since we don't apply force of paddling in y component. But instead, according to the statement here, this is directed towards positive x direction. That is why we will automatically assume that F sub Py here is 0. So in this case, our F sub Py, or the component of force in the y component but of the force of paddling, is equals to 0. Okay, so the answer for the F sub Px of force of paddling is 17 newtons in x component, and in y component the F sub Py is 0. So we've done about analyzing or resolving the x and y component of force of paddling, and now let's have to resolve the force of the wind. So let's try to isolate this one, this force here, or the diagram here. So solve for, so to solve for the F sub Ax, we're going to copy again the diagram there, and our force of the wind according to the diagram that we have is directed towards north of east. This is our F sub A, and this is the angle of 67 degrees, and with that we have the F sub Ax component of that, and this is directed towards x component, of course, and we have also F sub Ay, which is directed towards y component. So this is F sub Ay. So by analyzing this one, we're going to use the applications of basic trigonometric functions. So for solving for F sub Ax, we're going to use the cosine function, and you can also review, you can go back to our lesson in components of vectors so that you can be refreshed about this concept here. So to solve for F sub Ax, F sub Ax is given by equation of F sub A cosine of let's say 67 degrees, and this is the equation for the force of the wind in the x component. Now to solve for F sub Ay, we're going to use the sine function. So this is F sub Ay is equals to F sub A sine of 67 degrees, and this is now the force of the wind in the y component. So let's try to highlight this one. So we have now the x and y component for the force of the wind, and also let's go back to that. We have also x and y component for the force of the paddling. And next thing to do is to solve for the summation of forces. When we say summation, we're going to solve the total net force or net force of the forces in x and y components. Solve for net force, or shall we say summation of f sub x, net force in the x component. So summation of x or force in the x component is equals to f sub px plus f sub ax, and this is equals to, we will get the forces along x component. So the force for the f sub px is 17 newtons. So we will substitute here 17 newtons plus the force of the wind in the x component is in the f sub ax component. So this is equals to fa cosine of 67 degrees. So this is equals to 17 newtons plus, you substitute the value of f sub a, which is this one, 15 newtons. So this is 15 newtons cosine of 67 degrees, and this is equals to 17 newtons plus 15 newtons cosine of 67 degrees is equals to 6 newtons, and this is equals to 17 newtons plus 66 newtons is equals to 23 newtons. So the summation of f sub x is equals to 23 newtons. So let's solve for net force in y component, or summation of f sub y in y component. So summation of f sub y is given by f sub py plus f sub a y. So this is equals to, let's go back to this equation here. F sub py here is equals to 0. So we can simply substitute value of 0 newton to this variable here. So 0 newton plus f sub ay is given by this one, given by this equation here. So this is equals to f sub a sine of 67 degrees. So this is equals to 0 newtons plus substitute the value of the f sub a, which is equivalent to 15 newtons here. So this is equals to 15 newtons sine of 67 degrees, and this is equals to 0 newtons plus 15 newtons sine 67 degrees is equals to 14 newtons, and 0 newton plus 14 newtons is equals to 14 newtons. So the summation of force in y component is equals to 14 newtons. And since we are, to summarize this one, let's try to have a summary of this value. So in the x component we have 23 newtons of force, and in y component we have 14 newtons. So by applying the second law equation here, which is given by force is equals to mass times acceleration, we can now substitute, or we can replace this one, this variable here into that. So this is equals to summation of f sub x is equals to mass times a sub x, and for y component this is summation of f sub y equals mass times a sub acceleration sub y. So since this is the variable here is available, meaning to say we have that, the computed value for that, and the value for summation of f sub y is also available. We have also computed value for that, and this one is given, which is equivalent to 1,300 kilograms of given mass that can be found in our problem. So it's time for us to solve for the acceleration of the raft in terms of x and y components. So to do that, let's try to solve first. Solve for a sub x. Summation of f sub x is equals to mass times a sub x. Divide both sides of the equation by m. So this is equals to a sub x is equals to summation of force in x component divided by mass. And this is equals to summation of force in x component is 23 newtons divided by mass is 1,300 kilograms. And this is equals to 23 newtons divided by 1,300 kilograms is equals to 0.018 meters per second squared. Newtons here is equals to kilograms times meter per second squared divided by kilogram here. So kilogram to kilogram will be cancelled out, and the remaining unit is a meter per second squared. So the unit is meter per second squared. And the answer for a sub x is equals to, or acceleration in x component is equals to 0.018 meters per second squared. Next is solve for acceleration in y component. Divide both sides of the equation by m. So this is a sub y is equals to summation of force in y component over m. Substitute the value for force in y component, which is 14 newtons, divided by 1,300 kilograms. And this is equals to 14 divided by 1,300 will give us 0.011 meters per second squared. So the answer for the y component acceleration is 0.011 meters per second squared. So this is the approach, or this is the example for the applications of Newton's law, second law of motion, which is the vector nature of the second law of motion. If you have some clarifications regarding this topic here or example problem here, you can directly go to our group chat and type your question there. Once again, this is Mads, and see you in the next video.